What time is it right now on Mars? Simple question. Mars is about 12 light minutes away. So you might think, well, I'll account for the light travel time, calculate back, and figure out what's happening on Mars right now. But that's wrong. There is no right now on Mars. Not in any absolute sense, not in a way that all observers would agree on. The question is meaningless. Now is not a universal concept. It's observer-dependent, relative. Different observers moving at different velocities will disagree about what events on Mars are happening now, and none of them is more correct than the others. This is one of the most profound and disturbing consequences of Einstein's special relativity. There is no universal present, no cosmic moment that separates past from future everywhere in the universe. The notion of now that feels so immediate and obvious, the sense that there's a single present moment advancing through time, is an illusion. I'm Leonard Susskind, and I'm going to explain why you can't define now, why simultaneity is relative, why different observers slice space-time into different presents, and why this means the universe doesn't have a privileged current moment advancing through time. Let me show you why. Starting with the most important experiment in relativity, Einstein's train thought experiment. You're standing on a platform, a train rushes past at high speed, lightning strikes both ends of the train simultaneously from your perspective on the platform. You're standing exactly in the middle, equidistant from both strikes. The light from both reaches you at the same time, simultaneous strikes. But there's someone on the train, also in the middle of the train car. The train is moving toward where the front strike occurred and away from where the back strike occurred. So the light from the front strike reaches them first, then the light from the back strike reaches them later. They conclude the front strike happened first. You conclude both strikes happened simultaneously. Who's right? Both of you. There's no absolute fact about whether the strikes were simultaneous. Simultaneity depends on your reference frame. Events that are simultaneous in one frame are not simultaneous in another frame moving relative to it. This is not an optical illusion. It's not about light travel time confusing you. This is what simultaneity actually is. The strikes were simultaneous in your frame. They were not simultaneous in the train's frame. Both descriptions are equally valid. Neither is more true than the other. Now, here's the critical point. If simultaneity is relative, then now is relative. What you call the present moment, the set of all events happening right now, is different from what someone moving relative to you calls the present moment. Your now is a different slice through space-time than their now. Let me make this precise. In space-time, you can think of now as a three-dimensional surface, a surface of simultaneity. All events on that surface are simultaneous from your perspective. That's your present. But if you're moving at a different velocity, your surface of simultaneity is tilted differently through space-time. Your now includes different events. And here's where it gets really strange. The tilt can be significant over large distances. Imagine Alice is on Earth, Bob is in a spaceship traveling toward Andromeda at 99% the speed of light. Andromeda is 2.5 million light years away. What events in Andromeda does Alice consider now? She draws a surface of simultaneity through space-time, a flat slice perpendicular to her time axis. Events on that surface are simultaneous in her frame. If she could somehow see Andromeda instantaneously, she'd see it as it is now in her frame. What events in Andromeda does Bob consider now? He draws his own surface of simultaneity, but because he's moving at high speed toward Andromeda, his surface is tilted relative to Alice's. How much? At 99% light speed toward Andromeda, Bob's now in Andromeda is about 800 years ahead of Alice's now. Let me say that again. Events that Bob considers to be happening right now in Andromeda are 800 years in Alice's future. Events that Alice considers to be happening right now in Andromeda are 800 years in Bob's past. They disagree by 1,600 years about what's happening now in Andromeda, and both are correct. There's no absolute answer. Now, suppose Bob turns around and starts moving away from Andromeda at 99% light speed. His surface of simultaneity tilts the other way. Now, his now in Andromeda is 800 years behind Alice's. Bob just shifted what he considers the present moment in Andromeda by 1,600 years, just by changing his velocity. He didn't change anything in Andromeda. He changed his motion, and that changed which events he calls now. This is the relativity of simultaneity, and it destroys any notion of a universal now. Now, let me connect this to the block universe, because this is where the philosophical implications become unavoidable. If there's no universal present, if different observers have different nows, then what exists? The answer relativity forces on us is that all of space-time exists, past, present, and future, all equally real, all part of a four-dimensional structure called the block universe. In the block universe, time is a dimension like space. The Big Bang, the formation of Earth, your birth, this moment, your death, the heat death of the universe, all of these exist as part of the four-dimensional space-time structure. There are different positions along the time dimension, but they're all equally real. There's no moving present advancing through time. There's no moment where reality is. The entire history of the universe, all of it exists as a static four-dimensional block. Your life is a world line through that block, a path from birth to death. Every moment of your life exists along that world line. You, at age 5, exists at one space-time location. You now exist at another space-time location. Both are equally real. Both exist in the block. What you experience as the present moment is just where you are along your world line. The subjective sense of time flowing is your consciousness experiencing each point along the world line in sequence. But from the perspective of space-time itself, all moments exist simultaneously. This is called eternalism, or the B theory of time, and it's the natural interpretation of relativity. Now, I know this feels wrong. You experience the present as special, as real, as the only moment that exists. The past feels gone, the future feels unreal. This is presentism, the idea that only the present exists. But presentism is incompatible with relativity. If only the present exists, who's present? Yours? Alice's? Bob's? They disagree by centuries about what's happening now in distant places. There's no way to pick one observer's now as the real one. They're all equally valid, which means all events they consider now must exist, which means past and future must exist too. Relativity forces eternalism. Now, let me address an objection. You might say, fine, simultaneity is relative at cosmic distances, but surely I can define now locally. Right here, right now, this moment that's real. Yes. Locally, you can define now to excellent approximation. Within your light cone, the region of space-time, you can causally influence the differences between reference frames are negligible unless you're moving at relativistic speeds. For events nearby, now is well defined enough. You and I, sitting in the same room, agree about what's happening now to within nanoseconds. The relativity of simultaneity matters, but barely. It's only over large distances or at high velocities that now becomes ambiguous. But here's the thing. Physics doesn't respect local approximations. The laws of physics are the same everywhere. If simultaneity is relative in principle, then now is ill-defined in principle, even if the effect is small in practice. There is no absolute cosmic present, and that's a fact about space-time, not an approximation. Now let me tell you about surfaces of simultaneity in curved space-time, because general relativity makes this even more complicated. In special relativity, space-time is flat. Surfaces of simultaneity for inertial observers are flat planes tilted at different angles. In general relativity, space-time is curved. Surfaces of simultaneity are curved too, and they can be defined in multiple ways. For a single observer, you can define a surface of simultaneity as the set of events at which the observer's proper time has a particular value. But different observers following different paths through curved space-time will have different surfaces. And there are situations where no global surface of simultaneity exists at all. In cosmology, for example, the universe is expanding. There's a natural cosmological time defined by the expansion cosmic time, and you can use that to define surfaces of simultaneity. But that's a choice. It's not unique. In space-times with closed time-like curves, paths that loop back in time, you can't define consistent surfaces of simultaneity at all. The notion of before and after becomes circular. General relativity makes now even less well-defined than special relativity does. Now let me tell you about the Rietvik-Putnam argument for eternalism. Suppose an event E is in your future. It hasn't happened yet in your frame, but there exists an observer for whom E is in the past. It already happened in their frame. So E both hasn't happened yet and already happened, depending on who you ask. But if E already happened for some observer, it must exist. Existence isn't observer dependent. So if E exists for any observer, it exists, period. Future events exist. The block universe is real. This is one of the strongest arguments that relativity forces eternalism. Now let me address cosmological time. In an expanding universe, there's cosmic time defined by the expansion. Observers at rest with respect to the cosmic microwave background agree on this time. This gives cosmology a preferred time coordinate. You can ask how old is the universe and get a meaningful answer about 13.8 billion years since the Big Bang. Does this restore universal now? Not really. Cosmic time is a convenient choice, not a forced one, and observers moving relative to the cosmic rest frame still have different nows. General relativity makes now even less well-defined than special relativity does. Now let me address quantum mechanics, because some people argue quantum mechanics restores a universal now. The argument goes like this. Wave function collapse is instantaneous. When you measure an entangled system, the wave function collapses everywhere simultaneously. That collapse defines a moment of simultaneity, a universal now. But this doesn't work, because simultaneously, in which frame? The collapse happens on a surface of simultaneity, but that surface is observer-dependent, just like in classical relativity. Different observers moving at different velocities would say the collapse happened at different times in distant regions. There's no universal collapse moment. Moreover, most interpretations of quantum mechanics don't have collapse at all. Many worlds has no collapse, just continuous unitary evolution. The wave function never collapses, so there's no collapse-induced universal now. Quantum mechanics doesn't save presentism. Now let me tell you about causal structure. Because while now is ill-defined, causality is absolute. Events in space-time are related by causal structure. For any event, space-time is divided into three regions. The past light cone, events that could have causally influenced this event. The future light cone, events this event could causally influence. And the elsewhere region, events too far away to be connected by light speed signals. The elsewhere region is where simultaneity becomes ambiguous. Events in your elsewhere can be in different temporal order for different observers. One observer says event A happened before event B. Another says B happened before A. Both are right. But events in your past light cone are unambiguously in your past for all observers, and events in your future light cone are unambiguously in your future for all observers. Causal order is preserved. This is why relativity doesn't create paradoxes. You can't send a signal to your own past because no signal can travel outside the light cone. Causality is protected even though simultaneity is relative. So while now is observer-dependent, causally related is absolute. The structure of space-time preserves cause and effect even as it destroys absolute simultaneity. This is a subtle but crucial distinction. The block universe doesn't mean everything happens at once. It means all events exist in space-time with definite causal relationships. Your birth causes events in your life. Those events cause your death. The causal chain is real even though the present is not. Now, let me tell you something that bothers me philosophically. If the block universe is correct, if all moments exist equally, then why do we experience time flowing? This is the hardest question, and I don't have a complete answer. Here's the partial answer. Your brain is a physical system. It processes information sequentially. Memories form of earlier states. Anticipation forms of later states. This creates the subjective experience of time flowing from past to future. But the flow is an artifact of how your brain processes information. It's not a feature of space-time itself. Space-time is a static, four-dimensional structure. Your consciousness is a pattern in that structure, experiencing each moment in sequence, creating the illusion of flow. Think of it like a movie. The entire movie exists on the film reel. All frames exist simultaneously, but when you watch it, you experience it frame by frame. There's a subjective sense of progression even though all frames exist simultaneously. Your life is like that. All moments exist in the block universe, but your consciousness experiences them in sequence, creating the illusion of time flowing. That's the best answer I can give. It's not fully satisfying. The hard problem of consciousness, why we have subjective experience at all, is not solved. And the hard problem of time, why we experience temporal flow, is connected to it. But what we can say for certain is this. The subjective experience of time flowing does not require an objective flow of time in space-time. The block universe is compatible with our experience. Now, let me tell you why this matters for how you think about your life. If the block universe is correct, then your entire life already exists. You, at every age, every moment from birth to death, all exist in space-time. The future is as real as the past. Does this mean your choices don't matter? Does this mean the future is predetermined? No. Your choices are part of the block. They exist in space-time as causal nodes. The future is determined by those choices in the same way the past is determined by them. The fact that the future exists doesn't make it unchangeable by you. It just means your actions, your decisions, your choices are all part of what determines it. You can't change the future because you're part of what creates it. Think of it this way. In a movie, the characters' choices determine the plot. The fact that the entire movie exists on the film doesn't mean the characters' choices are irrelevant. The choices are what the movie is. Similarly, your choices determine your world line. The fact that the world line exists in space-time doesn't make your choices meaningless. The choices are what the world line is. Let me end with a question. What time is it on Mars right now? The answer is, there is no answer. Not because we don't have enough information, because the question assumes a universal now that doesn't exist. You can pick a reference frame and ask, what time is it on Mars in this frame right now? That question has an answer. But different frames give different answers, and none is more correct than the others. Now is not a feature of the universe, it's a feature of your perspective, your reference frame. Your slice through space-time. The universe doesn't have a present moment. It has all moments, past, present, and future, existing together in the four-dimensional block of space-time. And your experience of now, That vivid, immediate sense of this moment being real is your consciousness experiencing one point along your world line in the block. There is no universal now. There never was. The sense that the present is special, that it's the only moment that exists, is an illusion created by how your brain processes time. The universe is a block, and you're a path through it. That's what special relativity tells us. And once you understand it, you can never see time the same way again.